let's talk about some access control patterns with Cognito. So when we develop our applications, then we usually have some point of entry to the application, like an API gateway, if we apply REST type APIs, and we want to protect that point of entry. We want to protect our endpoint. And Cognito is exactly that service that helps us protecting those endpoints. In my earlier workplaces, as far as I can remember, when we discussed architectural patterns, and we mentioned Cognito, the opinions were well quite ambivalent. So developers said that we don't really want to use Cognito because it's difficult, it's complex, it's hard to use, it has a learning curve. Absolutely. So Cognito has a learning curve for sure, but in my opinion, it has gotten much easier with the new UI. So I will start with a general introduction to Cognito. So what Cognito is, and I will mention the two components of Cognito. And then I will talk about how Cognito integrates with the API gateway. So there is a direct integration between Cognito and the API gateway to control access to an endpoint. Then I will mention some challenges and how we can address those challenges using Lambda triggers. And finally, at the end, we will have the questions and answers sessions. But before doing that, let me introduce myself. My name is Arpad, and I'm a champion AWS authorized instructor as well as an AWS community builder. I just started my 5th year a few weeks ago, and I regularly write posts and now create videos as well on serverless and the security topics. I most often about the combination of the two. And as Csaba mentioned, I'm also a Syntax Nebula instructor. So what is Cognito? Cognito is a serverless service, which means that we don't have to manage the underlying infrastructure. Cognito helps with authentication, authorization, and user management for web and mobile applications. And this is important. So we are not talking about access control to AWS services like S3. That's IAM. We just heard about that from Julia. Cognito is about protecting applications that we develop. Cognito has two components. First, we have the user pools. Cognito user pools is an OAuth 2.0 and OpenID Connect compatible identity provider. It's a user directory, which means that it stores users' username, password. It manages sign-up flows, sign-in flows, forgotten password, multi-factor authentication. So, manages sign-in with third-party trusted identity providers like Google, for example. So that's user pool. Identity pools, on the other hand, is different. Identity pools return temporary AWS credentials. So temporary AWS credentials for authenticated, that is signed in, trusted users and unauthenticated or guest users. Now this presentation, this talk will focus on user pools only. So I mentioned that Cognito user pools is an OAuth 2.0 and OpenID Connect compatible service. Let's see what that means and how it works. So let's say that we have a guest. Our guest is called Alice, and Alice booked a wellness weekend in a hotel. She deserves it. She works very hard, so she wants to spend 3 or 4 days in a hotel. So upon Arriving at the hotel, first she goes to the reception and she will present her ID card. Now, the ID card will have her name, date of birth, and any other pieces of information that the receptionist needs. Now, the receptionist will check if Alice is actually Alice, and then, if everything goes well, and of course the booking is paid, the receptionist will give Alice a key card, those plastic cards. Alice then will go to the elevator, she will go up to the 3rd floor, and she places the plastic card in the slot on the door. And if the card is coded properly, that means the card belongs to the door will open, and Alice can enter the room. Now, this is just a normal hotel check-in process. Cognito user pools works in a similar way. Now we have a user, and our user is called, again, Alice. She goes to the reception, that reception is going to be Cognito user pools, and presents her ID. In this case, her ID is username and password. The user pool will check if Alice's credentials, that is ID, are correct, username and password. If so, then the user pool will issue the plastic card, the key card, the access token. Then the application, Alice, through the application, will go to the door, the hotel door, will call the endpoint with that access token. And if the access token is configured properly, that is, it contains the needed properties, the endpoint API gateway will allow the request to proceed. Otherwise, it will deny the request. Now, one important thing here. The access token, just like the plastic card, has no information about the user. It's totally separated. So if I steal this card, I can enter Alice's room. So the identity is checked by a trusted identity provider. In our case, it's going to be Cognito user pools. Now let's see the same thing in a bit more detail. So again, Alice signs in with Cognito user pools, and the Cognito will issue 2 tokens. Most of the time, it will issue 2 tokens. First, the access token. We already talked about that. Now, this is the OAuth 2.0 compatibility. And it also issues an ID token. And the ID token is the OpenID Connect compatibility. The ID token contains information about the user. The access token is for controlling access to endpoints. The user pool will return these tokens to the application, and the application will call API gateway with one of these tokens in the authorization header. Ideally, that's going to be the access token. But API gateway can also sort of handle ID tokens. But in this case, API gateway only checks if the token is valid. So if it's not expired, it hasn't been manipulated, it comes from Cognito. If we want to control who can access what, that is, if we want to control that Alice can access endpoint number 1, but she cannot access endpoint number 2, then we will need to implement additional logic with the ID token. We don't necessarily need to do that with the access token, and this is what we will see soon. Both ID and access tokens issued by Cognito are JSON web tokens, and this is an example for the access token. So here you can see the token use property. It says access, so that means it's an access token, and this is the key here, that property, the scope property. Now the scope property or claim has a string value, and as you can see, that string has multiple strings. If the access token contains the substring that the API gateway endpoint expects, then API gateway will let the request proceed. If it does not contain the expected substring, API gateway will deny the request. But here's a challenge. That scope claim needs to be claimed in the request. What does it mean? It means when a user authenticates, that is the /authorize endpoint is called, then the request, the authorization request, must contain a scope property in the query parameter. So if we want Alice to have, for example, the tasks::read permission, then the request, Alice's authentication request, must contain the tasks read substring in the query string as the value of the scope parameter. Now, this is not a problem if we have like 2 scopes and 2 users. But what if we have a fancy to-do application where we have many scopes and we want Alice to have these 2 permissions, then we want to have Bob those permissions. We want our admins to have all of these permissions. So how will the front end, the client, know what to put here in the request? So we can handle that on the front end side, but in my opinion, it's better to delegate this responsibility to Cognito, because Cognito's job is to handle authentication and authorization. And we can use Lambda triggers for this task. Lambda triggers are just normal Lambda functions which alter or modify the behavior of the Cognito user pool. So as you can see, there are 4 types or categories for Lambda triggers, and inside those categories there are multiple options that we can do with Lambda triggers. We can customize welcome messages, we can create capture challenges, find all the bicycles in the image. So those types of challenges. At whatever stage we connect our Lambda trigger to, Cognito will interrupt the authentication flow at that point. It will invoke the Lambda function. The Lambda function will do its job. It will return a value to Cognito, and then Cognito will continue its flow with that new value. Now let's see how it works on a diagram. So again, we have Alice, our user, and Alice is placed in the read tasks group in Cognito. So we can create groups in Cognito, just like we can create groups in IAM. We can do the same thing in Cognito, and we can put users into those groups. So Alice is in the read task group. So she will enter her username and password. She authenticates to the user pool. And after that happens, after the user pool ensures that Alice is actually Alice, but before the tokens are issued, we can interrupt that process with a pre-token generation Lambda function. So at that point, Cognito can invoke that pre-token generation trigger function. Now that function, again, this is just an example. You can do whatever you want. This function connects to a database. In this case, it will extract the group information from the input, its read tasks, the group that Alice belongs to, and fetches the permissions, the scopes that belong to that group. The function will then return those scopes to Cognito, and Cognito then will put those scopes in the access token. Now, if the application and Alice, through the application, calls an endpoint which is protected by the read permission, API gateway will let the request proceed. Why? Because Alice is in the read task group and the read scope is attached to that group. But if Alice tries to invoke an endpoint that is protected with a write permission, she won't be able to do that because API gateway will deny the request because Alice's scope don't have the write permission. Let me show you that in the code. Yeah, it's written in TypeScript. Other programming languages do basically the same thing. The main part here is that the Lambda function, the pre-token generation Lambda function, needs to return the input event as well as a response object. And here, access token generation. So you want to modify the access token or influence the access token, and scopes to add. And here, in this array, we will list these permissions. So that's how Cognito will know that that it needs to add those permissions to the access token. Let me show you that in the console very quickly. So we are in the user pool. So I go to users, and as you can see, I have two users, Alice and Bob. Let's click Alice, and as we discussed, Alice is in the read tasks group in Cognito. Moving on to API gateway. Now this to-do application is still in progress. So it only has one endpoint, the task endpoint, and here we have a get and post endpoints. Now, if I go to the get endpoint, then we'll say that it's protected by a Cognito authorizer. So API gateway and Cognito works together in this case. And what API gateway expects is this string, that sequence of characters, to do API/tasks::read. So if the access token contains that sequence of characters, API gateway will allow the request to proceed. Now, quickly, let me show you the post endpoint. And this is very similar. The only difference is that it's protected by the write permission. So let's see that's application. So here we have Alice, and let me log in Alice. There we go. And here. Now the entire process has just finished. Cognito did the authentication check. The Lambda function has already run, and we'll see that these are the scopes in the access token. Because Alice is in the read group, these are the scopes in the access token. Let me just quickly show that to you. So I go to jwt.io, and there we are. So this is token use access, and here, this is the scope that we need, that the API gateway will need. So if I head over to the tasks menu and I click the get tasks button, which is connected to the get endpoint, then I expect it to work because Alice's access token contains that claim. But if I click the create task button, which is connected to the post endpoint, I expect it to fail because it's protected by a write permission, and Alice's access token does not have that. So I go back to tasks, create task, and indeed, API gateway declined the request straight away. It does not even let it go to the backend. It will just cut it off immediately. So that's Alice, and let's quickly sign in Bob, and let's see what happens to Bob. Now quickly, let me show you Bob in the users. Now Bob is part of both groups, read task and write task. So we can have users in multiple groups, so the Lambda function can handle that as well. And as expected, Bob's permissions are both read and write. So here I expect that both endpoints will work, and indeed. So this is one way that we can configure Cognito and API Gateway to control access to endpoints based on users and user groups. So that's about it. What I wanted to share with you today. And are there any questions?